Upbeat, energetic music fades in, then lowers to a background hum. You've heard it 1,000 times. Maybe in a heated Facebook comment section, or from that one uncle at Thanksgiving. If humans evolved from apes, why are there still apes? It sounds like a mic drop moment, right? A perfect gotcha. And it's the cornerstone of a massive, persistent myth that evolution is just a linear ladder where one species turns into another, and the old one disappears. But here's the truth, that question is based on a fundamental misunderstanding of how evolution actually works. And today, we're going to tear that misunderstanding apart, piece by piece. We're going to look at the fossil evidence, the genetic proof, and the simple biology that shows humans didn't evolve from the apes you see at the zoo. We share a common ancestor with them. And by the end of this video, you'll not only understand the difference, you'll be able to debunk this myth yourself. Let's dive in. Music shifts to a more focused, investigative tone. So, let's start with the core of the confusion. The phrase humans evolved from apes is technically incorrect. It's a sloppy shorthand that leads to the exact logical trap we just described. The correct statement is, humans and modern apes, like chimpanzees, gorillas, and orangutans, share a common ancestor that was an ape. Think of it like a family tree, not a ladder. You and your cousin didn't evolve from each other. You both evolved from a shared grandparent. Your grandparent didn't vanish when you were born, they just continued existing, and then you and your cousin went down different branches. The same is true for us and chimpanzees. Around 6 to 8 million years ago, there was a population of apes in Africa. That population split. One branch eventually led to modern chimpanzees and bonobos. The other branch eventually led to us, Homo sapiens. That ancestral ape population didn't look exactly like a modern chimp or a modern human. It had its own unique features. But it was, without a doubt, an ape. Now, let's look at the evidence. First, the fossils. We have an incredibly detailed record of human evolution, with hundreds of fossils that show the gradual transition from that common ancestor to us. One of the most famous is Australopithecus afarensis, better known as Lucy. She lived about 3.2 million years ago. She was small-brained, about the size of a chimp's, but she walked upright. Her pelvis, her knee joint, and the angle of her femur are all clear evidence of bipedalism. She wasn't a human, and she wasn't a modern chimp. She was an intermediate form. Then we have Homo habilis, or handyman, from about 2.4 million years ago. They had slightly larger brains and started making simple stone tools. Then Homo erectus, who emerged around 1.9 million years ago. They were taller, had even larger brains, and were the first to control fire and migrate out of Africa. Their skulls show a brow ridge that's less pronounced than earlier species, and their faces are flatter. Then we see Homo heidelbergensis, and then Homo neanderthalensis and Homo sapiens. Each fossil is a snapshot, a branch on that family tree. They don't form a straight line from a chimp to a human. They form a bush, with many branches that went extinct. But the overall trend is undeniable, a steady increase in brain size, a reduction in jaw and tooth size, a shift to fully upright walking, and the development of complex culture. But here's where the skeptic might say, those are just bones. You can interpret them any way you want. And that's where genetics comes in and absolutely crushes the argument. We can now look directly at our DNA and compare it to the DNA of other apes. The results are staggering. Humans and chimpanzees share about 98.8% of our DNA. That's not just a coincidence. It's exactly what you would expect if we shared a recent common ancestor. And we can even use this genetic data to build a family tree. When scientists compare the DNA of humans, chimpanzees, gorillas, and orangutans, they get a branching pattern that perfectly matches the fossil record. The genetic distance between humans and chimps is smaller than the distance between chimps and gorillas, which is smaller than the distance between all of them and orangutans. It's a perfect, nested hierarchy. And we can even use a molecular clock to estimate when these splits happened. By counting the number of genetic mutations that have accumulated in each lineage, we can calculate that the human-chimp common ancestor lived about 6 to 8 million years ago. That matches the fossil evidence for the oldest known hominin, Sahelanthropus chadensis, which dates to around 7 million years ago. So, why does the myth persist? Part of it is the power of a simple, catchy question. If we evolved from apes, why are there still apes? It's easy to remember and repeat, but it's also a failure of imagination. People imagine evolution as a linear progression, where one species transforms into another in a single, smooth line. But evolution is about populations, not individuals. A population of apes didn't suddenly give birth to a human. Over thousands of generations, natural selection favored traits that were beneficial in a changing environment. Those early ancestors who could walk upright more efficiently could travel farther for food. Those with slightly larger brains could make better tools. Those with smaller jaws and teeth could process a wider variety of foods. These small advantages accumulated over millions of years, generation after generation, until the descendants of that original ape population looked very different from their cousins who stayed in the trees. And those cousins, the ones who stayed in the forest, continued to evolve too. They became modern chimpanzees and bonobos, perfectly adapted to their own environment. They didn't stop evolving. They just took a different path. Let's address another common objection. If evolution is real, why don't we see it happening today? But we do. We see antibiotic resistance in bacteria, which is evolution in action. We see the evolution of the peppered moth in industrial England. We see the evolution of dog breeds from wolves over just thousands of years. The difference is that human evolution operates on a much longer time scale because we have long generation times. But we can still see evidence of recent evolution in our own species. For example, the ability for adults to digest lactose, the sugar in milk, evolved independently in several human populations within the last 10,000 years, after we started domesticating cattle. That's a genetic change driven by natural selection. We also see evidence of ongoing evolution in our immune systems and even in the shape of our skulls. So, let's return to that original question. If humans evolved from apes, why are there still apes? Now you know the answer. You didn't evolve from your cousin. You share a grandparent. We didn't evolve from chimpanzees. We share a great-great-great-grandparent with them. That grandparent was an ape. And just like your grandparent didn't disappear when you were born, that ancestral ape population didn't vanish when our lineage split off. Some of its descendants stayed in the forest and became modern apes. Others moved into the savannah and became us. The fact that modern apes still exist is not a problem for evolution. It's actually exactly what the theory predicts. It's evidence of a shared history, a branching tree of life, not a linear ladder. Music swells to a warm, conclusive tone.